continuing with the connective tissue, we're going to look at cartilage. Cartilage is going to be one of the support tissues along with bone to support your skeletal structures. And we have three different types of cartilage. Now all the cartilage, this is a cross section of your trachea. And we have in the trachea the rings that go around that kind of feel like a vacuum cleaner hose in your throat. Those are made up of what's called hyaline cartilage. And if you look at the hyaline cartilage here up close, you'll see that the cells are living in their own little houses. The houses are called lacunas. And all the cartilage will have their cells in little housing units. They might be close to each other, even closer here, or they may be totally separate. Now, the difference between the three cartilage is going to be the matrix, the material in between the cells. You want to look at this and in your mind come up with what you think makes it look different. When I look at hyaline cartilage, I feel this looks more like a jello. It's smooth, not ripply, okay? And you're going to find this to be the most common of the cartilage in your nose and in your trachea. Then the next cartilage we're going to look at is elastic cartilage. Now here we can see this is part of our epiglottis. Our epiglottis is the structure that goes over the trachea when you're swallowing food. And elastic means it can spring back into shape. You can pull it down and then it can jump back up. So here we have the cartilage. Again, the cells are in their own little houses. But we now have in between it some very dark elastic fibers that have the ability to expand and then spring back. So that will give away the elastic cartilage. Looking at the cells, you can see over here the cells of the hyaline cartilage with the smooth matrix, the cells of the elastic cartilage with the dark black elastic fibers. And the third type of cartilage we have is called fibrocartilage. In this case, it's going to be extremely fibrous. Now here you can see the cells, and I think the material in between the matrix looks almost like cement. It looks very grainy and fibrous. This is a picture of your pubic symphysis. This is a connection between your what you would think of as your pubic bones that holds the two bones together, and it's just a cartilage pad between the two. The next group of tissues we're going to look at are going to be our dense tissues. Now they are called dense because, different from the loose ones, they have a large number of fibers, and the fibers can either all go parallel to each other or they can go in an erratic formation. So dense because there's a lot of fibers compared to the loose, which had very few fibers. And this is called dense irregular because it's all parallel. You don't even really see too much in the way of the cell's nuclei. You can just see all the fibers going in one direction. We're going to find this in our tendons and our ligaments. Your tendons are what hold muscle to bone, and your ligaments are what hold bone to bone. We have a special type of dense tissue, and this is special because it not only has the collagen fibers, but we also have some of the dark elastic fibers. So this is going to allow this to expand and then spring back. We're going to find this type of tissue in the wall of our aorta, which is the largest artery in the body that is under a lot of pressure when the blood comes out, and then it has to spring back to its original size. And then the last type of dense connective tissue we have, and I have two pictures, we're going to look at them side by side, is what's called dense irregular. This is a very lightly stained slide. So the dense irregular here, it's got a lot of fibers, but it looks more like, parcel wood or plywood, where you have some fibers going in one direction, some going in another, some going in another. So it's kind of erratic, although the bundles are all parallel. It's got a number of different bundles going in different directions. You're going to find this in your skin. This is the scalp, and in this picture we have the foot. We do not have it magnified, but all of this is dense irregular, and you can see the erratic pattern. And the purpose of this is for protection. This gives you a good layer where if you step on something, it might make it through one part of the dense irregular, but it might not make it through the next section of dense irregular because it's going in a wide variety of directions.